Hello everyone, myself Ajay. I think all of you are at home and all of you are very safe. And the last topic that we have covered, I think that was formation of image by convex mirror as well as sign Cartesian and the convention rules. All those things we have learned. So in this video, we are going to learn some of the things like mirror formula, the magnification, and a little bit about the reflection of light. Okay, so the first thing, I don't know how many of you remember. I would like to recall that lesson name. What is the lesson name? Light. Okay, lesson name is light. Say, suppose this is the concave mirror, right? This is the concave mirror, right? This side will be the and this one will be the reflecting surface, we all know. And the center of the sphere will be the pole, right? Then we will pass an imaginary line. It is called as the principal axis, right? Here it will be the center of curvature. When we draw a complete sphere here, there will be the center, and that center called as the center of curvature. Now the midpoint of the middle point of the center of curvature and from the pole, it is called as the focus, right? The distance from the focus to the pole is called as the focal length, right? Now suppose, and another one thing also we learned, if the object is placed above the principal axis, then it is taken as positive. If it is below the principal axis, it will be taken as negative. And always the object is placed towards the left of the mirror, it will be convex or it may be concave. Okay, and this side it will be always negative, and this side will be always positive. Why? See here, for example, these are the axes. Okay, this is y dash. Okay, x dash, x, suppose, and this is what we call as the y axis. This is what we call as the x axis. If you know the graph, then you can understand, right? This will be, upper side will be positive and this will be positive. Here it will be negative and it will be negative. Similar thing you have to see here, right? Now here, now suppose upside of the this principal axis, it will be positive, and downwards it is negative. See, upwards positive and downwards negative. To the right positive, to the left negative. Okay, now what we have to do here is, suppose here the object is there, A, B. Okay, and an object has formed a real image. Okay, suppose here at this point, what we say, A dash and B dash. Now what we have to learn in this one is the distance of the object from the pole. The distance of the object from the pole, it is taken as u. Okay, it is taken as u. It's very clear. Now the image is formed here at this particular point. The image is formed of the object, right? Now the distance of the image from the pole, is taken as v. Right, is taken as v. Now the distance between the focal and the distance between the focus of the principal to the pole is called as the focal length. That is here. Now here actually there is one relation. There is one relation between u, v and f. Okay, there is a relation, that is 1 by u plus 1 by v is equals to 1 by f. So this equation or this relation between the distance of the object, distance of the image from the pole, and here also from the pole, and the distance from the focus to the principal, that is focal length, that is the relation, and that's the relation is called as the mirror formula. This is called as the mirror formula. This is applicable for all types of spherical mirrors. here we have to note down another one thing. We should keep our one thing in our mind whenever we use this formula in numericals, that we have to use the sign conventions properly. Okay, we need to use the sign conventions properly. Suppose the center of curvature is given minus 10 or minus 5. Suppose it is in a minus. So what do we mean by this negative sign? Means it is the center of curvature is towards the left. Okay, if it is given in a positive, means the center of curvature is towards the right. Okay, right. If the object height it is given in the negative, means it is below the principal axis. If it is given in positive, then above the principal axis. Right. These are the things. These are the sign conventions which we have to use very carefully. Right. So very clear, it is distance of the object from the pole, that is u, distance of the image from the pole, that is v, and it is the pole, it is always measured from the pole, right? And the focus, from the focus to the pole, it is called as the focal length. Now there is a formula for the focal length also. F is equals to r by 2. F is equals to r by 2. Now suppose if the question comes like the radius of curvature, now what is the radius of curvature? From the center of curvature, the distance from the center of curvature to the pole, the distance of center of curvature to the pole is called as the radius of curvature. Always remember, okay, the distance from the center of curvature to the pole, it is called as the radius of curvature. That is the radius of curvature is given, suppose at 10 centimeter. Okay, not 10 centimeter. Now it is asking us to find out the focal length. Okay, how we can find out? Just half of the radius is the focal length. Half of the radius is focal length. ये focal length है, समझे यहाँ से यहाँ पे focal length. इसका half हमें क्या मिलता है? Focal length. तो यहाँ पे r is equals to 10. So f is equals to 10 by 2. It will be 5. Right? The focal length is 5. Right? It's very clear. Is it clear? Okay. The next thing that we have to learn is, suppose another one thing. If f is given or the focal length is given, then we can find out the radius of curvature. If the radius of curvature is given, we can find out the focal length. Okay, there will be the relation. And this relationship, this mirror formula, actually in a previous year or any other year, whatever it is, we need to derive the mirror formula. But now at the present moment, there is no need to derive the mirror formula, because from the syllabus which is given presently, now in that syllabus the derivation of the mirror formula is not there, and it is not coming in your exams also. What is coming? Only these things, right? The relationship between the distance of the object, image of the object, distance of image of the object, and the focal length. Okay, and this formula is called as the mirror formula. It is called as the mirror formula. Okay. The next thing what we have to learn in this video is magnification. Okay. Right. So better you will take the screenshot of it. Okay. Right. A magnification is very simple. You just understand. See what we have to learn. Magnification. Magnification is the ratio of height of the object to the height of the image. That is what we call as the magnification. In a simple manner you can understand. Okay. So I will write out here magnification. Magnification is the ratio of height of the object to the height of image. and the magnification is always given in the form of m, or we can say it is denoted by m. As per the definition here it is given, the magnification is the ratio of height of the image, height of the object to the height of image, right? So okay, just a little bit rearrangement here we can do. The ratio of height of image to the height of object. Okay. I beg pardon. Sorry. Okay. Now, by the definition, how we can write it? H dash, height of the image. H, height of the object. Height of object. Right? It's very simple. This is the thing. And another one thing you should remember, that magnification, it is related to the distance of the object u, okay, and distance of the image v. Distance of the object u and distance of the image v, and this same equation can be represented like this: m is equals to minus of v by u, minus of v by u. Okay, so in this form also we can express it, right? हमने यहाँ पे क्या किया है? Magnification का definition क्या रहेगा? Magnification is the ratio of height of the image to the height of the object, and it is always denoted by the m. So it can be like the height of the image divided by height of the object. Height of the image is h dash and height of the object is h. Okay, so very simple, right? Fine. And another one thing you remember always, that if the value of m, if the value of magnification comes in a negative, okay, comes in negative, okay, if suppose the value of magnification comes in a negative, then you remember that the image is real, the image is real and erect, okay. And the second thing, if m comes in a positive, the value of magnification, if it comes in a positive, then you should remember that it is a virtual and real and inverted, and virtual and erect. Okay, so this is a very simple thing, right? And we know that, say how it is. Suppose magnification value comes in a negative, means again if you take the axis here, this is x dash and this is x, so y dash, and we know that this is positive, this is negative means to the left of the mirror, always we know that is the negative, and to the right of the mirror is positive. Upward above the principal axis is positive and below the principal axis is negative, that also we know, right? So if the magnification comes in a negative, means towards the left, where the rays of light actually intersect with each other at point, and that point is called as the point of intersection, right? And when the ray of light appear to come from the particular point and they are intersecting it in an imaginary way, then that point will be always behind the mirror, that is virtual. Okay, so there is a difference. In the real one, they are actually intersecting with each other, but in the terms of in the case of virtual, they are not actually intersecting. They appear to intersect with each other. This is a simple thing about the mirror formula as well as the magnification. Okay, right.